Okay, we can start off with this session. More than session, this is what we actually want to happen, like you talk to each other. That is more important. This is pretty big room. It would have been good like if we had a small room. It looks like there is nobody listening when you see from here. Yeah. Okay. So the objective of this session was mainly to cover what has been done so far on Android on ARMv8 and what else needs to be done. So generally, like as you saw in the keynote demo, like we demonstrated Android running on ARMv8 and there is also hardware expected soon. So devices expected soon. So it looks like almost an Android port for ARMv8 is done, but still there are a lot of things which are missing, which we need to do. So in this session, like I'll just highlight few main areas which we think we should go after from here, like whatever we have done so far. So from here, we need to pick few more areas and really look into those. But I'm very open to your inputs on what exactly we need to focus on, and if something which I'm talking, if it is not relevant to ARMv8 or something, please feel free to ping me. So generally the sessions we had before were all like joint sessions, right? Like where the audience involvement or the members involvement is very much required. So this I don't want to run in a presentation mode where I'm going to talk and you're just listening, but feel free to stop me anywhere. Let's discuss more on what exactly we are discussing and whether it is relevant for ARMv8, whether we should do it or we should not, or if there are any more any other important items which we need to be picking instead of what we are going to present here. So I'm just checking if key guys are here. So going with what Stuart was saying in the previous slide, so previous session. So Juno with Android on ARMv8 was announced in July. So this was the work which we have been doing with ARM and Google also joined lately, and this has been like first version, public version was announced in July. So this is not like we implemented something in the last month, but it is like an year kind of or 2 years kind of work that actually came in together, and we made a first official release in July on the actual hardware platform, and the release is publicly available for all of us to download. So this release is on Juno hardware development platform. So this platform is available from ARM. Most of our members, I think, already have this platform, and they are already using our releases for in-house development as well as for validation and so on. So this is where we were, and on Android side itself, like at AOSP, there were a lot of things which were added for ARMv8. So on Android user space, like as we just discussed, so ART, JNI, Valgrind was done from ARM partners, and then Bionics, Kia, RenderScript. I think there were a lot of key frameworks which are modified in AOSP to get it compatible or get it running on ARMv8. On the kernel side, like a lot of patches, kernel work on Android 60, like ARMv8 was like tremendous. A lot of work has been done even before Android work started, and a lot of patches went upstream. And then we saw that LSK was important because our members and Google and everyone was depending on a stable kernel instead of migrating along with the moving kernel versions. So we at Linaro we do both the tasks. Like one, we have LSK, which is based on 3.10 today. So where we have Android completely tested for production, and we also have upstream kernel which is also being maintained, and we have a lot of patches, or the actual development that is going on the kernel side is on upstream. So when the patches go upstream, we also pull it in LSK and then maintain in 3.10. So both the tasks are going on for latest kernel as well as LSK. And on the tool chain, so GCC 4.9 is fully supported today, and we continue to work on GCC till we see a complete migration to other tools and compilers. Also, we work with Google. Last year when we were here at Connect, we gave a lot of presentations, and there were other sessions that we presented at Android Builders, and we also worked closely with Google Android team to identify the projects in external folder. Like if you go to Android external project, like you see more than 170 plus Android projects, which are uh, which are derived from Linux user space, but they are being used in Android for like if you see OpenSSL or any codecs or so on. So they are being used in Android as well. So we worked with Google in order to migrate these projects to the latest versions. So there were these projects were on bit older versions, so we validated it for latest versions, and they so we migrated basically to the Google pulled all the latest versions of these external projects in Android AOSP. With that, we get all the support for ARMv8 and latest bug fixes and so on. So the performance improvements, like moving from SQLite, which was older version, to the newer version of SQLite, just moving to the latest version gave like 20% improvement in SQLite itself. So similarly, there were many improvements done in external projects which were not being picked in Android AOSP, so which were pulled. So and also like ARMv8 work was being pulled in this. So yeah, definitely thanks to ARM for working with Google and partners like Linaro and others for getting all the ARMv8 stuff into AOSP. On Linaro side, we continued working on ARMv8 Android for long time. Like we started with Android 64-bit and 32-bit user space with the 64-bit kernel. So we were releasing this to our members and to ARM to stabilize the kernel side first, because we wanted to validate Android user space on a 64-bit kernel. So that activity continued for us for almost a year, and where we were finding CTS issues, where we were finding a lot of framework issues and so on, where we used to hack basically. So those patches were not in AOSP because they were almost like hacks, but the work was really hard for us to keep Android maintained for 64-bit kernel. So after doing that, we migrated to like when Google started supporting Android for 64-bit user space. So we started working on the AOSP master and like work on AOSP master with 64-bit user space, and 64-bit kernel picked up very fast, and it was completed within no time. So it was very quick. And after the launch of this Juno platform, so we are now actually working on hardware, but earlier we used to work on fast models of and ARMv8 soft models for Android as well. So a lot of work has been done, as I said, on LSK, keeping the LSK stable, and also on the upstream stuff, doing a lot of upstream work, keeping Android maintained for migrating, moving GCC versions, so 4.9 and so on. Like earlier, it was 4.8. 3D graphics. So from Linaro, like every month, we make a release, which is like pre-integrated release from like we have release which we look at, and if there are any major bug fixes and value adds, we pick those things. We pick kernel changes from upstream, we integrate into LSK. We have Mali drivers from ARM, which we integrate into AOSP, and then we have every month we pull the latest AOSP master, and then we run a thorough CTS test suite on this, and then also individual tests to validate Bionic and ARM codecs and so on. So after validating and then pre-integration, so this release is being done every month. So it should help our members to baseline their software on our releases and start developing their code base. So, and also we focused on few optimization areas which were very key. With ARMv8, we get like OpenSSL was more optimized for ARMv8, and that really gave a significant improvement. Few areas we optimized for neon, but still there is a lot of work to can be done in that sense. And we also enabled SC Linux by default, and there were few issues with that, and we were able to resolve. And our Android default releases have SC Linux enabled builds now. So this is what was done at Linaro with respect to like till 14.08, like which was our previous release. So we continue to work on that. So this is what has happened till date, and where do we want to focus next? So as I said, like I have very few basic ideas where we think we should put our effort, knowing that Google Android team is also working on multiple frameworks and also working on L, and there is a lot of things which were announced at Google I/O like Project Volta and so on. So a lot of work is happening at Android teams in Google for ARMv8 as well as L and so on. Similarly, our ARM team is also working on very key differentiators for ARMv8. So now it's our response, and our members also have, like most of our members have L access now. They are also working on ARMv8. So there is also engineering teams working on actual hardware. So if you see, the development effort is happening at Google, at ARM, at our members. So Linaro should play something like where we go really fix the important pieces, give some foundation software, and also see that we are having some, we are trying to identify and fix some key issues for our members and the complete ARM ecosystem itself. We don't want to add any redundancy to the work that our members or Google is doing. Like if things are being done by some team, I think we should only try to consider that work than doing any redundant effort. So definitely that will be one of the key input. Like if you guys are already are doing some work, then let us know. Then we can actually stop doing that or do focus on something else. So I have prepared some few items which we think we should focus on. Like first item is definitely on Android L. So what are we going to do on Android L? At this point, for at Linaro, we don't have sources for Android L. So we, like based on our interactions with the Android team and knowing how the things are going in AOSP. So one thing that we are trying to do is we are trying to be on tip of AOSP master. Like this is where the changes from L are also getting in, right? So we are trying to be on AOSP tip so that we get all the changes that are happening for L, and we validate it every month with LSK and other pieces of software like Mali and graphics and video and so on. So that is one key thing that we want to do, like continue to maintain on AOSP master for ARMv8. So also keep integrating, as I said, like Mali and so on. Identify issues with 3D graphics integration, like if there are any issues with respect to Bionic updates and the run CTS. There are still few issues with the packages in CTS which might have to be solved. So look into those things. So keep SC Linux enabled by default to catch any bugs early. And the other top item that we are also focusing on is at LMG we have identified some list of benchmarks which are key for our members to run ARMv8. Like as soon as the software is up on any ARMv8 hardware, the first thing that members are doing or members are interested to do is run the benchmark and see what the numbers are. Like compare it with their ARMv7 numbers and ARMv8 numbers and see whether really they are seeing these performance improvements and so on. But in order to run that, first the benchmark itself should run, right? So there are issues that we found that few benchmark applications are still not running. Maybe they are because of software compatibility, or it might be hardware issue, or it might be something else. So we want to identify we have identified a list of benchmarks which we think are important for our members, not from the results, or we are not focusing on the results of the results. We are not focusing on the numbers, but we are actually trying to get the benchmark running itself. So that was one of the key items that we have for this connect in our hacking session. So we have a couple of Juno boards where we want to really try out all these top few benchmarks and ensure that they are working for our members to pick. So this is one of the to-do items that I have listed, and feel free to reject it, and just we can focus on something else. And on Linux side, like as I was saying, there is a lot of work being done on the upstream, and there is also a lot of work that is done on LSK, and also like we need to see when LSK moves from 3.10 to 3.14 or so. So this work is completely done by our Linux kernel team or kernel working group. So upstream work is being handled there. So you will see, I think we have a session in LMG Lightning Talks to highlight kernel features. So there you will get to know more into like where we are in each of these topics. On 3.10, we will continue to integrate all the upstream work that is happening for kernel. So we will try to port it back to 3.10, and we will make a release every month. 3.14, I think it is almost ready. If someone has any doubts there, maybe we can check with our LSK team. But we are not migrating unless we see that Google also migrates to 3.14 or any latest LSK. But till then, we will continue to be on whatever version is being used for AOSP. On neon optimization, so this is one area which again I want to work with ARM team. We have been doing this task or reviewing these neon optimizations with ARM team as well. So there are still we find there are few areas which can be optimized for neon in external projects, which can be applicable for Linux as well as Android user space. So this is some basic list that I have, but we need to again I'll walk through this list with members as well as our ARM team to see if this really, if there is really a gap in for neon optimizations in this space, and if this is applicable. And based on this, we can probably consider this as a roadmap item for LMG and work in coming months. On tools, definitely there is a lot of focus now on tools in LMG that we have. Like Tom and Kanta, they have put together like a list of things that we have to do for Android. So the basic requirement here is like there are a lot of tools in Linux community to there are a lot of tools in Linux community which we can bring in for Android as well. So we want to investigate those tools. A lot of things are already there, but we also want to see like if there is something good that we can leverage from the Linux part. Apart from that, like migrating to GCC 5.0, this is one of the item that we want to be focused on. As soon as it is out, we want to continue working on. Today we are picking latest of GCC. Like Bero is sitting there at the back and he is trying to solve the GCC issue for our 14.09 release. So we are on tip on the GCC side there. We also did an NDK release last month. So this was based on AOSP master. Generally, if you see NDK releases are available every 3 months to 4 months time from Google itself. So the idea here was like ARM is pushing a lot of patches to NDK, and they are not going to be available for our members to test till like 3 or 4 months. So instead, we worked on this task of pulling AOSP master, NDK from AOSP master, and trying to get it run on the Juno hardware development platform using Linaro GCC toolchains. So it was tough this time for us. Like Bero had to spend again 2 to 3 weeks to at least 2 weeks to get it working, and it was a bit hard because a lot of things were seemed to be like broken. So we managed to fix those things, and the release was done last month. So similar exercise we want to do every 1 month or 2 months to give our members like early access to NDK for validation purposes. So this is on NDK, and then GCC 5.0. Clang is always an important item for all of us. We have been discussing this for the last 2 to 3 connects on migrating to Clang completely. The key requirement there is like we are waiting for Google to completely move to Clang, and lot of projects are already on Clang, few projects are not on Clang. So we are talking and making sure that we are picking all the latest changes on Clang. So our goal is also to make sure that we have in-house work being done for Clang migration. So as soon as we see similar work being done in AOSP, we will be doing the same for our releases as well. There is also a requirement from our members to work on memory usage analysis and optimization. So I pulled this slide from one of our discussions that Tom is having in LMG. So this is basically to see when we have Clang and GCC. So what issues? So this is mainly profile and benchmark and see if there are how the memory usage and the memory footprint is between these two compilers, and also like do compiler optimization level analysis and see like where they are. So this task is more of like profiling and benchmarking and finding the bottlenecks in memory and finding the bottlenecks in the memory footprint and usage as such. So this task is given a high importance. So we need to really look into what exact tools we would use for measuring the performance, and how do we produce the results, and how do we infer the results basically, and say whether it is very important, whether there is any scope for improvement, and if it is, then we need to really go and look into those areas as well. So I had a question, like if there is any requirement for us to look at 64 and 32-bit addressing from Android image as such. Maybe I'll discuss it offline with somebody. On power and boot, like we are waiting for Volta things to stabilize in Android AOSP and get released. So until it is released, we don't know exactly what to be done in Project Volta. So all the information that we have is basically like on the specs and things. That will really not help us to make a task for us to work on. So we generally want to wait there and see what exactly is being done in AOSP. So other thing is like boot time investigation. So we did a thorough investigation of boot time and measurements last year, and we presented at Connect last year, and we found that a lot of work was being done, a lot of time was being pulled by Zygote. Definitely there are a lot of areas which can be a lot of frameworks and modifications can be done to get the boot time optimizations, but they like from our understanding, these things will not end up in AOSP because there will be like a lot of hacks required. So we have an app note that we implemented last year which shows like what you can do to get the boot time optimization reduced. So it is an application note that we released last year itself, but we generally don't want to do it because you can't get that sources into AOSP. So we just want to recommend like how you can achieve the best boot time possible for your products. The other thing that we are looking at is, which again has to be further discussed at LMG SC, basically is to see if we can get Tux on Ice kind of thing ported for Android. So this is one of the discussions that Tom will be having in deep dive with LMG SC. On the other things, like on the multimedia codecs, again I need to discuss this with Frank and Ashok here from ARM and Google, basically to understand like if there is. So one thing that I feel is I took this note from the media codecs page that Android maintains. So from an application developer point of view, they definitely need multimedia codec support in order to test and validate their applications. But if we see from our members, they'll basically have a lot of hardware accelerators for each of these codecs. So in the end product, it is the hardware accelerated codecs which will eventually go and will be used. But from the development point of view, like when I am developing some app, or when I am testing some framework, or when I am doing any active development, if it is broken because the hardware accelerator is not there, then it will actually stop my work as well. So in order to facilitate that work, we basically want to have multimedia codecs completely enabled, optimized for ARMv8. So this is one task that we are looking at if we really want to. I think majority of these codecs are already running for ARMv8, and some of them can be improved and optimized for ARMv8 with Neon. So that is one exercise which we want to do. Apart from that, like we worked closely with ARM on identifying some automated test suite for multimedia codec. This has come out really well. Like last 6 months back when we were discussing, I was not very sure like how we are going to do this in terms of automation, but it has been done, and it has been done very good. Like there was an assignee from Broadcom, Edmund and Ashok, they worked together to come up with this automated media test suite. So this has been used for our Linaro multimedia testing, and we plan to continue improving these tests. So this is basically done as with respect to MD5 sum. So you run a known sample and then on an access device or something, collect the output and then compare the same results on ARMv8 and see if you're really getting similar MD5 sum. So that will give you that codecs are running fine in an automated environment than just looking at the screen or some or hearing to audio itself. So this has come out really well, and we plan to improve this test suite, and it is available for our members to download from Linaro Android user space tests. So we have kernel tests as well as user space tests. So these test repository is being maintained, and if any of our members are interested to participate in this, they are more welcome. And also, like if there are any other user space tests that they want to contribute or maintain it, so they can publish it or upstream it here, so it gets maintained for all of us. So if in your organizations you have any Android validation or test that you want to make it public or want to find a better portal for those user space tests, I think this is the right thing to do. So other thing is like on builds and validation. So I was, this is definitely a not a right list to work with our builds team. This is going to be very risky to prepare so many builds, but I was just thinking like what other builds apart from LSK and AOSP master will help our members in terms of validation. Like will AOSP master and upstream kernel be the right build that we need to have? Like by build I mean at Linaro, we have automated build system and automated validation system. So this is one of our good infrastructure that we have that is available for our members. So if there is a hardware platform, you can put it in our Lava and have the build set up. So on daily basis, your build will get generated and then it will automatically get tested and you will see the results in the dashboard. So with this, we can basically try to catch any bugs that are there on daily basis or weekly basis whenever we need. So in that build, like I was thinking, what combination should we basically try? Should we try GCC 4.9 as well as Clang? Should we have a build for upstream kernel as well as LSK kernel? Today we are only running AOSP master and LSK. So similarly, we can add more builds if we want to focus on. So this is one area that we can explore. So also, like as I was saying, running benchmarks and profiling apps is one thing that we are also looking at. Implementing a new audio video codec testing is also one area that we are looking at from validation point of view. So this is the list I had, which I said like have populated based on our discussions and the member interest, and also seeing that we are not doing any redundant work with other teams across our ARM ecosystem. So if there is anything that you think should be added into our list of to do for ARMv8, we will be more welcome to add those. If you think some of these things are not relevant or we need not focus on these things, please feel free to update that as well. We can consider that. So I'm open for questions. Hey, Jonathan, how are you?
Question was that you tested different combinations of 32-bit and 64-bit applications running on 64-bit Android, and noticed any performance issues with switching back and forth or robustness of both types of applications you look at on a process level?
So we ran multiple applications. So we ran around 50 to 60 different apps last month, and we found like few of them were failing. We really don't know why they were failing. So we had we were not having access to the platform at that time. So we have access to ARMv8 hardware now, so we want to really investigate that. So as I was saying, like in this week we will be rerunning those applications again and seeing whether they are related to any framework or compiler issue or NDK or 32 and 64-bit issues. So I had a general talk with Sharban like in one of the calls. So one thought that Sharban said was like, because some of the things were failing for us because we were not having complete um, list of devices that are needed, like audio was not there for us on Genome, or Wi-Fi was not there or something, so things were breaking for that. But otherwise, in generic terms, we are not seeing any issue in running a 32-bit app or 64-bit app on ARMv8. So that exercise we have done, like both NDK apps as well as native apps we were able to run, and we didn't find any issue as such. But the requirement that we are trying to focus on is like pulling latest apps from the market and seeing whether they are working or not working. So that part is still under in progress. You want to add to that anything, Sharban?
So I actually have a talk about some of this stuff on Thursdays, which I encourage you to participate to. From a platform point of view, Juno is a development platform, not a device. So it doesn't have things like Bluetooth or Wi-Fi and so on, which are mandatory for a phone. But from an architectural point of view and the way that 32-bit and 64-bit and multi-lib works together in Android, there should be no reason for 32-bit applications not to work on your 64-bit ARM64 platform. So there should be no such reason. I was discussing with Khasim, and most of the applications that were failing because they were querying SD card or Wi-Fi connection that wasn't existing. We have a hacking session and we have a couple of Juno boards. So if you have any issues or want to get up to speed with AOSP and ARM64 development, feel free to nag me and or any other member from our team or from Khasim's team, and we'll be able to help. Thanks. Yeah, I can.
No more questions.
So do you have any benchmark scores comparison like V7 and V8? So what is the CPU speed? You have any numbers for any of the benchmarks like Quadrant or Antutu?
We generally don't publish benchmark numbers. As I was saying, like our main goal is to get Quadrant running on ARMv8. So then we'll let members run their own between their own SOCs and compare the results. So personally, we don't maintain these benchmark numbers. Otherwise, definitely from ARM you will get a lot of benchmarking and these type of numbers for is CPU specific or Neon specific, and these things you should be able to find.
So this is related to memory. So when you compare 64-bit instruction set and 32-bit instruction set, so only you will gain in the data section, right? So is there any other sections you will gain in memory? 64-bit instruction set and 32-bit instruction set.
So is this a comparison between ARM and ARM64 as architecture? So there are lots of advantages of ARM64 compared to 32-bit ARM. We have more registers. The vector floating point unit is mandated for operating systems, so the ABI won't be soft float, it would be hard float as a default. We have different views of the registers, so from an architectural point of view, ARMv8 is an improvement of ARMv7. And again, I'll be discussing about some of these improvements in the talk I have on Thursday. I think it's from zero to boot NanoDroid. I hope this answers your question. Okay.
So one thing you could do, I should mention, I'm the person who's been working on ILP32, so that could be something that Linaro could work on for Android too. Why not? Well, and then just get rid of the last. Just get rid of ARM32 then. So the idea is, since you guys just mentioned, ARM64 has a lot of benefits, why not support ILP32 except for the downfall of having to support a little bit more? Really? Would it be? I don't think it would be that much more. Except for, well, userland wise, yes, but kernel wise, you only have one. Okay. Yeah, I can see that.
An excellent way to bridge between 64 and 32. But if once you've already made the jump to 64, adding it in again, when you've already got 32-bit support and other architecture support becomes probably more expensive than the effort justifies.
So if there are no more questions, so I just put up the next slide for the next presentation. So this is going to be an interesting session. So let's see. It should start at 12:10, so there is 10 minutes break.